All right, everybody, we are in Tennessee Reveal Geometry, and this is lesson 4.2, which is on translations. And a translation is basically taking a figure and shifting it somewhere, shifting it up, down, left, right, or a combination of all of that. All right, so it looks like we're going to be talking about probably a vector if they're giving us, well, there it is right there, magnitude. All right, so here is a great example of a translation. You're taking one object, triangle ABC, and we're translating it by this vector right here to JKL triangle. So basically, let's talk about what a vector is. It's an initial point, which is where your dot is. That's your beginning, and your what's called a terminal point, and that is your ending or where it's going to. So, for instance, this magnitude is 1, 2, 3, 4, 5 to the right and 2 up. So we're shifting A 5 right to up to become J. B is 5 right to up to become K. And C is 5 right and 2 up to become L. So this is what magnitude is, and this is what a vector looks like. All right, so let's see, get to an example number 1. Determine whether a translation maps triangle JKL onto, okay, let's talk about what these little tick marks are. They're called primes. So triangle J prime, K prime, L prime. If so, find the translation vector. If not, explain why. All right. Anything that is a regular letter like J, K, L is your pre-image. Your pre-image is your original figure. Anything that has primes like L prime, J prime, K prime, this is your image. So you have your original pre-image, and this is your new figure, which is called the image. They're wanting to know if this is going to be a translation vector. So basically what I'm going to do is pick one of the letters, does not matter which one, and you're going to see if it's the same throughout. So if I start at J and I want to go towards J prime, it looks like I'm going left, 1, 2, 3, 4. And since I'm not going up or down anything, I'm just going left 4. Well, if that holds true for L to L prime and K to K prime, then it is a translation. If it does not, then it's not. So let's look. All right, so here's my beginning, L. And if I go left 4 to get to L prime, we're in business. 1, 2, 3, 4. And since I don't, it's not a translation. Same thing for K to K prime. If I start off at K, 1, 2, 3, 4, I'm not on K prime. So no, this is not a translation at all. So a translation is the distance between each pair of corresponding vertices. It has to be the exact same for all 3 sets. J to J prime, L to L prime, and K to K prime. All right, if it's not a translation, nope. Move on. All right. All right, turning the translation of JKL. So this is my pre-image, this triangle, JKL, to the primes, J prime, K prime, L prime. If so, find the translation vector. If not, explain why. All right, so I'm going to start always with your pre-image and go to your image. All right, so start with J. Going to J prime. 1, 2, 3, 4, 5 to the right. 1, 2, 3 up. So it looks like it's 5 over 3 up. All right, L to L prime. 1, 2, 3, 4, 5. 1, 2, 3 up. Okay, so far it looks like it is, but we always have to try the last one. So K is 1, 2, 3, 4, 5 up. 1, 2, 3. All right, so it looks like it's going to work for all 3 vertices. J to J prime, L to L prime, K to K prime is right 5 up 3. So the answer is A. By the way, these little bracket looking things, this is called component form. It looks a lot like an ordered pair, but it's actually just the movement of the vector. So if I want to move right 5 up 3 for the vector, you put a little bracket, not a parenthesis. It's not like an order pair. Okay. Looks like there's an extra example online if you guys want to try it out. Example number 2. All right, scavenger hunt. Travis is on a scavenger hunt at the lake. He needs to swim to the nearest buoy, pick up a card, and then swim until he reaches a fisherman who will give him the next clue in exchange for the card. Excuse me. Describe the translation from the buoy. This is your initial point, to the fisherman's boat. This is your terminal point, by using the translation vector. So buoy is your beginning, fisherman's boat is your end. So it looks like we're going to have to go down 1, and then right 1, 2, 3, 4, 5. So it looks to me like the component form is going to be -1, 5. All right, so task 1, describe the task in your own words, and then list any questions you have. How can you find answers to your questions? Okay. So, yeah, it just looks to me like I'm counting. Okay, so it looks like from the buoy to the boat, I will have to count down 1 and then count right. What did I say it was? 1, 2, 3, 4, 5. Okay. So how you approach this task, you learn. Okay. So count it. So how you approach this task. I wish the easy breezy version is to count down and over. So it's a lot like, I guess it's a lot like slope. All right. So let's see. Approach this task. I'm just going to count. I mean, I won't make it any more difficult than what it is. So to count down 1, write 5. So what's your solution? Describe the location of the buoy in the coordinate plane. All right, so that's going to be the ordered pair 1, 2, 3, 2. The ordered pair 3, 2. All right, so I need an ordered pair. Oh, I found my component form there. There's that. All right, so ordered pair 3, 2. Okay. Not sure. Oops, backwards. All right, and describe the location of the fisherman's boat. So let's see, that's 5, 6, 7, 8, up 1, 8, 1. Okay, describe the direction of Travis's route. All right, so that would be down 1. All right, 5. All right, what is the translation vector? Okay, so this is where they want component form. So go back to geometry, click on the component form, and this was -1 for the down and +5 for the right. Okay. All right. So make sure I got everything right here. So we're going from the buoy to the fisherman's boat. Okay. Yep. Down 1, right 5. All right. Where was I? Yeah, your solution is reasonable. All right. So what argument? Apply the translation. Fisherman's boat. So let's put right there. I'm not sure exactly. I mean, they're trying to make it more complicated than what it is, y'all. Down 1, right 5. Going from the buoy to the fisherman's boat. Yeah, I'm not sure what they're wanting here. An argument that can be used to defend your solution. Slope, maybe? Slope is the same type thing, so I am completing a change in the y, then a change in the x value. I don't know if that's what they want, but this makes sense to me. All right, there's another version online or another example if you want to. All right, so let's go to, okay, so we're at practice already. So listen, you guys, very, very, very short lesson. So I want to click on GeoGebra to give you guys kind of a visual from a visual people. So I'm going to draw a triangle from the polygon, making up as I go. And I like to give myself nice ordered pairs. So there we are, there. All right, so let's say I want to do a translation on a vector. So I'm going to come to the 1, 2, 3, 4, 5, 6, 7, 8, 9th one over. And I want you to look at translation by vector. Now, when I click on that, down here it gives me the object that I have to select, or select the object to translate, and then the vector. So I'm going to select this triangle I want to move. Now, you've got to decide how you want to move it. So do you want to move it left, right, up, down, however you want to do this. So I'm going to give myself an initial point. And let's say that I want to move it right 1, 2, 3, up 1. So I'll go right 3, up 1, and I'll have to click to give myself my terminal point. And you'll notice that the figure does the translation for me. So same triangle, just moved it over. And then A prime, B prime, and C prime are created. So let's go back. Let's say that I've got my triangle and I want to have a go in downward motion. So I'm going to click on Translate by Vector, click on the object, and let's say that I want to move it in a downward motion. Down 1, right 5, like I did just a minute ago. 1, 2, 3, 4, 5. So there's my terminal point. And now I've got the same triangle. A has been shifted down 1, 1, 2, 3, 4, 5 to the right. C down 1, 1, 2, 3, 4, 5 to the right. B is down 1, 1, 2, 3, 4, 5 to the right to get to all my primes. So the nice thing about GeoGebra is this can also do it for you. Let me back up. Let's say I want to translate by vector. Going left this time. So I'm going to click on my triangle. And let's say I want to go down 1, left 2. All right, well, there it is. So the nice thing about this is it'll do it in any direction you want it to happen. All right, so I'm going to leave this with you guys. If you have any questions, ask your teacher or let me know. Ask me questions. I'm fine with that. I love questions. I love when you guys make me think. All right, so you guys have a great day, and I will talk to you later. All right, bye.